Okay, in this lesson, we are still working in section 2.3. We're going to be working with multi-step equations, and there's a couple of special cases that we're going to be looking at in this lesson as well. The first type is where you end up with an equation like 3 equals 3. Once you solve the equation, this is what type of answer you get. And in this type of problem, when the variables all go away, that means that it doesn't matter what x is, you get a true statement. This statement is always going to be true, so the answer is going to be all real numbers. Now, if you end up with an answer like 3 equals 5, where you end up with a statement that is not true, your answer is going to be no solution. So let's take a look at some examples. Okay, with all of these problems, we are going to simplify the equation first before we start using inverse operations and moving stuff from side to side. So with problem 1, I'm going to simplify the left-hand side. And again, if it helps to make this little dotted line down here and sort of just cover up the right-hand side and focus on the left-hand side, then you can do that. We're going to combine these two terms, 4x plus 6x, and that gives me 10x. So now I just have a basic one-step equation. I can divide both sides of the equation by 10, and I get x to be 3. On problem 2, again, I'm going to simplify the left-hand side, combine my like terms, and I get negative 2x equals negative 12. Then divide both sides of the equation by negative 2, x equals positive 6. Okay, problem 3, the first thing I'm going to do is to draw this dotted line down here to be sure that I'm keeping each side of the equal sign separately. I'm going to simplify what's on the left-hand side. I'm going to combine my like terms, so I'm combining this 6x and this negative 4x. And they combine to give me 2x, and then I'm going to combine my constants of 2 and 5, which will give me 7. So now I end up with a two-step equation, subtract 7 from both sides, and then divide by 2. So my answer is x equals 10. Now I want to look at a common mistake that students make. Again, I'm going to draw my dotted line down here. And what students a lot of times will do is they'll see this minus 4x, and they're so used to doing inverse operations, they will want to add 4x here and here and get 10x plus 2, say that cancels out, then I have plus 5 equals 27. Okay, what's wrong with this is that you can see here I've added 4x and 4x to the same side of this dotted line. So I've effectively added 8x to this side of the equation, and over here I've not added anything. So my equation is not equal anymore. Be sure that you understand that you're not getting rid of this 4x, you are combining it with the 6x. You're not getting rid of it and moving it to the other side by doing it this way. I need to combine my like terms. 6x minus 4x is 2x. Okay, with problem 4, I think that if I just gave you this problem and asked you to attempt this, then I think that most of y'all would start off this problem by trying to distribute. And that's exactly the way that I would start this off as well. Distribute the 2. So everything in the parentheses gets multiplied by 2. So this will give me 10x minus 8 equals 12. Then I'm going to add 8 to both sides of the equation. So 10x equals 20, and divide both sides by 10, x equals 2. On problem 5, again, I'm going to start off by simplifying the left-hand side, which means I need to distribute the 2. So this would give me 6x minus 2 once that's distributed. Then I combine my like terms. So I have 10x minus 2 equals 28. Then I'm going to add 2 to both sides of the equation, and then divide both sides of the equation by 10. Okay, problem 6, I need to distribute this negative 2. So this is going to give me 5x minus 4x plus 6 equals negative 9. Remember that when we distribute, I'm going to think of this as a negative 2, and this is a negative 3, and negative times a negative is positive. So now I'm going to combine my like terms. 5x minus 4x is 1x, which is the same thing as just x. And now I can subtract 6 from both sides of my equation. So x equals negative 15. Okay, here I have variables and constants on both sides of the equation. So I'm going to draw my dotted line down here to help me keep things straight. On the left-hand side, there's nothing for me to simplify. On the right-hand side, I can combine the 4x and the 2x to get 6x. Now I have variable constant on each side of the equal sign. I'm going to get rid of the smallest variable term first. So I'm going to get rid of that negative 3x, do the inverse. So you're going to add 3x. So I get negative 12 equals 9x minus 6. Then you're going to add 6 to both sides of the equation, and then divide both sides of the equation by 9. So x is going to equal negative 6/9, and that will simplify to negative 2/3. Okay, see here with problem 8, it's getting a little bit longer. What you need to be sure that you do first is to simplify each side of the equal sign. So on the left-hand side, I'm going to distribute and then combine my like terms. On the right-hand side, I don't have anything to distribute, so I'm just going to go ahead and combine my like terms. Now, you see that I have a variable and a constant on each side of the equal sign. So normally I would take the smallest variable term and get rid of that first. Well, they're both 2x, so if I'm going to follow that process and get rid of that smallest variable term first, you can see that the variables cancel out, and I end up with 14 equals 3. Well, 14 does not equal 3. That's not true. It's never going to be true. So the answer here is no solution. Now, sometimes you will see the answer written like this, which means the empty set. So that means if I was looking at all the numbers that make that true, then there wouldn't be any numbers that make that true. Now, I want to go back to this step right here. We're at 2x plus 14 equals 2x plus 3. I could have actually stopped right here because I know that this is never going to equal this. On the left-hand side, this is saying I'm starting with 2x and I'm adding 14. And that's going to be equal to the same thing as starting with 2x and adding 3. Well, if you start with 2x on both sides of the equal sign, that means that these two things are obviously equal. And you add 14 over here, that's going to give me the same result as adding 3 over here. Right? So adding 14 to one side of my scale or balance and adding 3 to the other side of the balance, they're not going to be balanced anymore. So I can see that this is never going to be true, so my answer is no solution. Okay, problem number 9. Again, I'm going to simplify each side of the equal sign. So on the left-hand side, I'm combining the two a terms, which will give me 1a or just a. And on the right-hand side, I get negative 21. So then I can subtract 2 from each side, and a is going to equal negative 23. Okay, problem 10, I'm going to simplify what's on the right-hand side. So I'm combining the 6y and 3y and getting 9y. Now I need to get y's on one side, constants on the other, so I'm going to subtract 9y from both sides. And that will leave me with y on the left-hand side. so y equals 9. Okay, before we get started with number 11, I do want to point out that there's more than one way to do these problems. But I'm going to try and stick with one consistent pattern for all of these. We're going to simplify each side of the equal sign first, and then use inverse operations. Okay, with problem 11, we're going to simplify the left-hand side first by distributing. So we get 12x plus 16. On the right-hand side, we're going to distribute that as well. So we get 8x plus 48. Now we have variable and constant on both sides of the equal sign. I'm going to subtract the smallest variable term first. So I have 4x plus 16 equals 48. Now I have a two-step equation, so I'm going to subtract 16 from both sides. So 4x equals 32. Then divide both sides of the equation by 4. So x equals 8. Now I want to go back to this step right here. So we have 4x plus 16 equals 48. If you don't want to write down that you're subtracting 16 from both sides and just go ahead and write the result of that, that's fine, and then divide by 4 and you get 8. So if you want to shorten your problem up by doing it this way, that's fine. Okay, with problem 12, I'm going to simplify the left-hand side. So I have 5x minus 4. Simplify the right-hand side. I have 5x minus 4. Now, if you want to follow the same process that we've been doing and getting rid of the smallest variable term first, well, you're going to get rid of 5x on each side, end up with negative 4 equals negative 4, which is a statement that's always true. So when your variable goes away, that means that variable no longer really matters. This is a true statement no matter what you put in for x, so your answer is all real numbers. Now, if you get to this step right here, and you realize that this side of the equation is the same thing as this side of the equation, then you really don't need to go any farther. This is what's called an identity. This is true for any x. The left-hand side and the right-hand side look exactly the same. That's always true, so the answer is going to be all real numbers. Okay, on this problem, I've got a variable and a constant on each side of the equal sign, so there's nothing for me to simplify. I'm going to subtract the smallest variable term. So get rid of that 7x. This gives me x minus 4 equals negative 4. Then I can add 4 to both sides of the equation. So x equals 0. Okay, I would like for you to try to do these two problems on your own. So pause the video, do these, and come back and check your answers. And there are your answers for 14 and 15.